Upon 1.1, we have to evaluate the integral of 4 multiplied by in brackets 1 over x minus e to the power minus x close brackets multiplied by cos of e to the power minus x plus ln x dx. This integral is not as bad as it looks because we can see that if we have to differentiate what's inside of our cos, we get what's in cos. So we can set what's inside of our cos as our u and differentiate our u with respect to x. Differentiating e to the power minus x, we get minus e to the power minus x. Differentiating ln x, we get positive 1 over x. From here, the next step, we multiply both sides by dx so that we can make du the subject of the formula. And rearrange our integral for clarity's sake. And also let's rearrange what's inside of that bracket. So we have minus e to the power minus x. And in this way, we can immediately see that this is the same as that one. So in the place of this, we can substitute our du. And in the place of e to the power minus x plus ln x, we said that we'll substitute our u. So we take the 4 out of the integral. Because u, with respect to u, we get sin u plus c, but our integral is not in the form of u, our integral is in the form of x. So let's substitute e to the power minus x plus ln x in the place of our u, and this becomes our final answer. Question 4.1.2, we have to evaluate the integral of 1 over the square root of 4 minus 9x squared dx. On our formula sheet, we have f of x and the integral of f of x dx. Our f of x, we are given as 1 over a squared minus x squared, and our integral, we are told that it's arcsine of x over a plus c. On our formula sheet, we have -1 as the coefficient of x squared, but in this case, we have -9 as the coefficient of x squared, so we have to rewrite our integral in this standard form. So let's take out the 9 as our common factor. Introducing the square root to this 9, we get 1 over 3 multiplied by 1 over the square root of 4 over 9 minus x squared dx. We can take the 1 over 3 out of the integral. And also let's write the 4 over 9 in this standard form. So we'll have 2 over 3 squared minus x squared dx. Using our formula to determine this integral, we'll have arcsine of x over a. Our a in this case is 2 over 3 plus c, and we can simplify. X divided by 2 over 3 will be equal to 3x divided by 2 plus c, and this becomes our final answer. For 4.1.3, we have to evaluate the integral of 2x squared minus 5x minus 1 all divided by x minus 3 dx. The method that you're going to use to evaluate this integral is long division. So we will have 2x squared minus 5x minus 1 long divided by x minus 3 x divided by 2x squared gives us 2x, and 2x multiplied by x gives us 2x squared. 2x multiplied by minus 3 gives us negative 6x. From here we have to minus 2x squared minus 2x squared gives us 0, minus 5x minus 6x gives us positive x. So x divided by this x gives us positive 1, and 1 multiplied by x gives us x, and 1 multiplied by negative 3 gives us minus 3. We have to take down that one. And from here we also have to minus x gives us 0, minus 1 minus 3 gives us positive 2. So since we are left with positive 2, we will divide positive 2 by x minus 3. So our integral becomes 2x plus 1 plus 2 over x minus 3 dx. Integrating 2x gives us 2x squared over 2, and integrating 1 gives us 1, and the integral of 2 over x minus 3 is ln of 2 multiplied by ln of x minus 3 plus c. And this will be equal to, that 2 will cancel that 2, so our final answer will be x squared plus x plus 2 ln of x minus 3 plus c. So this becomes our final answer. 4.1.4, we have to evaluate the integral of sine of pi x multiplied by sine of x over 5 dx. To evaluate this integral, we have to use our trigonometric identity, which is also available in our formula sheet as sin A multiplied by sin B is equals to 1 over 2 cos of A minus B minus cos of A plus B. But in our case, we have A as pi x and B as x over 5 minus cos, our A is pi x and our B is x over 5. So our integral is 1 over 2, so we can take the 1 over 2 out of the integral. Cos of pi x minus x over 5 minus cos of pi x plus x over 5 dx. And from here we can take our x as our common factor. So we have cos of x multiplied by pi minus 1 over 5 minus cos, and also we take our x as our common factor, x multiplied by pi of pi plus 1 over 5 dx. And from here we can integrating that cos, we have sine of x multiplied by pi minus 1 over 5 over pi minus 1 over 5 because of the chain rule, and integrating that cos, also you have sine of x multiplied by pi plus 1 over 5 divided by pi plus 1 over 5, also because of the chain rule, plus c, and this becomes our final answer. Question 4.1.5, we have to determine the integral of ln x over x squared dx. We can rewrite our integral as the integral of ln of x multiplied by x to the power negative 2 dx. And for this integral, we can use substitution because when we differentiate ln x, we get 1 over x and not 1 over x squared. So we have to use integration by parts, where the integral of f of x g prime of x dx is equals to f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. And the next step is for us to determine which is our f of x and which is our g prime of x between ln x and x to the power -2. And we use the eyelid rule, knowing that the first one that we come across going to the right on our eyelid rule platform becomes our f of x. So here we have a logarithmic function L, and here we have an algebraic function A, and the logarithmic function L comes before the algebraic function A. So ln x will be equal to f of x, and g prime of x will be equal to x to the power -2. The next step is for us to differentiate f of x and integrate g prime of x. When we differentiate f of x, we get 1 over x. When we integrate x to the power -2, we get negative x to the power -1. And from here we can substitute, so we have ln of x multiplied by x to the power -2 dx is equals to f of x multiplied by g of x. Our f of x is ln x, and our g of x is negative x to the power -1. So we have ln x multiplied by negative x to the power -1. So that negative, we put it there, minus the integral of g of x, which is negative x to the power -1. So that negative multiplied by this negative would be positive, and multiplied by f prime of x. So our f prime of x is 1 over x dx. So we can rewrite the 1 over x as x to the power -1. And x to the power -1 multiplied by x to the power -1, we get x to the power -2 dx. We can integrate x to the power -2, and when we integrate x to the power -2, we get negative x to the power -1 plus c. So writing our answer without the negative exponents, we get negative ln of x over x minus 1 over x plus c. 4.2, we have to determine the integral of x plus 2 divided by x minus 1 squared dx. And to determine this integral, we have to use partial fractions, where x plus 2 over x minus 1 squared is equals to a over x minus 1 plus b over x minus 1 squared. The next step is for us to multiply both sides of the equation by x minus 1 squared. This x minus 1 squared will cancel this x minus 1 squared, and we'll be left with x plus 2 on the left hand side, and we have to distribute this x minus 1 squared inside our parentheses. One of the x minus 1 squared will cancel this x minus 1 squared, and we'll be left with 1 x minus 1 . There are two methods that you can use to determine the value of a and b. The first method is for us to set x to be any number but the easiest number that we can think of are 0 and 1. So when we substitute 0 in our equation, we get 2 on our left hand side. That's 0 multiplied by that. A will be 0, so we'll be left with minus A plus B, and we substitute x is equal to 1. X 1 plus 2 is equal to 3, and A minus A is equal to 0, so our B will be equals to 3. So we can substitute our B into that equation. So when we substitute x is equal to 0 and x is equal to 1, we get that A is equal to 1 and B is equal to 3. You can use any number, you can substitute with any number, but the easiest numbers that you can work with are 0 and 1. With the second method, we have to equate what is on the left with what is on the right. So on the left we have x, and we also have 2, so you can say x is equal to, how many times on the right have x? It's only ax, so we equate the x to the ax. And on the right hand side, how many terms do not have x? It's negative a and positive b. So from here we have to solve for a and b. So when we divide both sides by x, we get that a is equal to 1, and we take this one, we equate it to our equation. Taking the negative 1 to the left, we have 2 plus 1 is equal to 3, so our b is equal to 3. So that integral will be equal to our a, we say that is equals to 1, our b, we say that is 3, so the integral of 1 over x minus 1 is equals to ln of x minus 1 plus the integral of 3 over x minus 1 squared dx. If you cannot readily solve this integral, I suggest that you use the u substitution method, where you let your u to be equals to x minus 1 and du over dx. Differentiating x gives us 1, differentiating negative 1 gives us 0, multiplying both sides by dx so that we can make du the subject of the formula. We get that du is equal to dx. So our integral, so we can take the 3 out of the integral, and we'll be left with u in the place of x minus 1, and we say that du is equal to dx. So in the place of dx we substitute du. This will be equals to ln of integrating u to the power negative 2 gives us negative u to the power negative 1. In the place of u, this minus multiplied by this positive will be negative. In the place of u, we can substitute x minus 1 plus c. Let's get rid of that negative exponent.